welcome back to Math with Mr. Antoine. I am Mr. Antoine, and oh, what's that? Oh, okay, that's the alert sound. We got solving inequalities alert. Okay, when you are solving inequalities, all right, and this is when you have when you're multiplying and dividing. So when you're multiplying or dividing both sides of an inequality by the same negative number, here's what you have to do. Change the direction of the inequality symbol. That's right. Change the direction of the inequality symbol. That's very important. So anytime we have to multiply or divide both sides of the inequality by a negative number, we have to change the direction of the inequality symbol. Okay, here's an example. We have negative 4a, which is negative 4 multiplied by some variable a, and is greater than 12. Well, in order for us to solve this inequality, we'd have to do the inverse operation, which is we divide both sides by negative 4. Now here it is. I'm dividing both sides by negative 4. And when, oh, you got the alert. So what does that mean? What we're going to do then is, since we're dividing both sides, we're going to get, this is going to be a, because negative 4 divided by negative 4 will leave me with a. We're going to switch and change the direction of the inequality symbol. All right, so it was once greater than, now it's a less than symbol. And then I do 12 divided by negative 4, which gives me negative 3. So what I have now as my solution set is a is less than negative 3. Now we're just going to check to see if that's true. All right, so let's do a check on it. A value that for a that's going to be less than negative 3 would be, let's say, negative 4, negative 5, right? These would be the values, negative 4, negative 5, negative 6, and so on. So let's do this. Let's use negative 5, okay, while we're doing this. So we rewrite the equation. This is going to be our check. So let's rewrite the equation, which is negative 4 multiplied by a is greater than 12. That's what we started with. So now we're going to put in, we'll use negative 5 for a. So let's put negative 5 multiplied by negative 4 multiplied by negative 5, which has to be greater than 12. And we know that negative 4 multiplied by negative 5, again, that's a negative times another negative, and that will give me a positive 20. And as it shows, positive 20 is greater than 12. Is that true? That is true. So it was right for us to change the direction of the inequality symbol in order for us to be able to make sure that we get the correct solution set. Now in this inequality, I have negative 1/3 is being multiplied to a, and when the product or the answer for that should be less than or equal to 5. So again, negative 1/3 times a is going to be less than or equal to 5. Now in this case, in the last inequality, we divided both sides by a negative number. For this one, in order for us to get the variable by itself, I'm going to multiply both sides by its reciprocal. And the reciprocal for negative 1/3 is going to be negative 3/1. So I'm multiplying negative 3/1. Let me just put that in parentheses so we can see it's going to be this what I'm multiplying this side by. By me multiplying the negative 3/1 times the negative 1/3, what's going to happen is it will both be canceled out, and what I'll be left with is just 1. So I'll be left with 1a on this side, okay? And then what I'm going to do is I'm going to do the same thing on the other side. I'm going to multiply this side by negative 3/1, which is the same thing as just multiplying it by 3. Okay, and see what happens here is, again, I got that alert button. So then again, what I have to do is I have to switch the inequality symbol. The inequality symbol is going to be switched, again, because I multiplied both sides by a negative with this inequality. So now, instead of it being less than or equal to, it's going to be greater than or equal to. And that's going to be A is greater than or equal to, that's 5 times negative 3, which will give me negative 15. All right, so A has to be greater than or equal to negative 15. So let's think of some values in the solution set. So if A is going to be greater than or equal to negative 15, well, it could be negative 15. It can be greater than that, so that'll be negative 14. It could be negative 13. It could be all the way up to 0. It could be 1, 2, 3. Hey, you know, we could do that. We could probably try some numbers even as positive. We could try 1, 2, 3. So let's do it. Let's just check to find out, even if we did a positive number, if it would work. So let's use 2. Okay, I'm going with the number 2. Well, matter of fact, to even make it easier, let me use the number 3. Watch what I mean. If I have now negative 1/3 multiplied by A, and it has to be less than or equal to 5. Okay, so let's try 3. 3 will be easy to use because if I have negative 1/3, and if I multiply it by 3, well, I can multiply it again. I could turn it to 3 over 1, and I want to see if that's less than or equal to 5. When I do the math of the negative 1/3 multiplied by 3 over 1, I am going to get a negative 1. And I got negative 1 is less than 5. Now, is that true? Is negative 1 less than 5? Yes, it is. So because this is a true statement, then that means that the solution set that we have of A being greater than or equal to negative 15 is going to be the solution set. Okay, there you go, people. That's how you do it. That's how you're able to, when you have dividing or multiplying both sides by a negative, by a negative number, what you have to do is change the direction of the inequality symbol. That's it for today for Math with Mr. Antoine. Have a good one. Keep doing math. Love and peace.